Gold has always been the ultimate symbol of power and immortality, a metal that never fades and holds the very essence of human ambition and wealth. But to claim this prize, we must descend into the depths of a literal hell, or scavenge the remnants of our own rapid technological advancement and waste. Welcome to a journey into the heart of the Mponeng mine, the deepest point on the planet, where humans battle extreme heat and pressure for every gram. Modern gold is no longer just found in the dirt. It is hidden in plain sight within the devices we carry in our pockets every single day. From the thunder of underground explosions to the silent precision of chemical reactions, the quest for the eternal metal requires the most advanced engineering on Earth. Join us as we explore the incredible technology that transforms raw ore and discarded electronics into the purest gold bars known to the modern financial world. Our journey begins 4 kilometers beneath the surface, at the Mponeng mine in South Africa, where the environment is as hostile as the surface of Mars. The descent takes several minutes, reaching speeds of 95 kilometers per hour as the air grows thick and the atmospheric pressure begins to crush the lungs. Down here, the rock temperature reaches 60 degrees Celsius, a heat so intense it could kill a human within minutes without massive industrial cooling systems. To make life possible, engineers pump thousands of tons of ice and chilled water from the surface to lower the temperature to a manageable 30 degrees. The miners work in narrow tunnels, using massive hydraulic drills to reach the thin veins of gold that were deposited here over 2 billion years ago. These veins are often no thicker than a fingernail, requiring the removal of tons of waste rock just to find a single handful of precious metal. Every blast carries the risk of a seismic event, as the massive weight of the crust above shifts and groans against the artificial voids we create. The logistics of Mponeng are a marvel of mechanical endurance, moving millions of tons of rock from the bowels of the earth back to the surface. Once on the surface, the ore is transported by gargantuan trucks, each capable of carrying 360 tons of rock in a single trip. This is where the physical labor of mining ends, and the complex science of metallurgy begins to extract value from the stubborn, unyielding earth. The rock is fed into ball mills, where it is pulverized into a powder as fine as flour, releasing the microscopic particles of gold held within. In a process called cyanidation, the gold is dissolved into a liquid solution, allowing it to be separated from the useless rocky sludge with high efficiency. The dissolved gold is then captured by activated carbon, which acts like a magnetic sponge, soaking up the metal from the vast volumes of liquid. This elution process strips the gold back into a concentrated solution, ready for the final stages of physical recovery and high heat refinement in the lab. Through electrowinning, an electric current pulls the gold out of the solution, plating it onto steel wool in a process that seems like modern-day alchemy. What remains is a thick, valuable sludge that bears little resemblance to the shining gold we know. Yet it is the product of months of labor. But there is another way to find gold, one that doesn't require digging 4 kilometers deep into the Earth's crust or fighting deadly underground heat. Urban mining has become the new frontier, as we realize that our discarded electronics contain a much higher concentration of gold than the richest natural ore. Statistically, 1 ton of old mobile phones can contain up to 60 times more gold than a ton of raw ore extracted from the Mponeng mine. Highly specialized robots and human workers dismantle these devices, focusing on the printed circuit boards where the majority of the gold and silver are located. The boards are shredded into tiny fragments, allowing for the mechanical separation of various metals before the final chemical extraction of the precious gold content. In the lab, we use aqua regia, a powerful mixture of acids capable of dissolving gold, turning solid metal into a vibrant, translucent, orange liquid solution. This liquid gold is then filtered and treated with chemicals to force the gold to precipitate out as a fine, pure metallic powder at the bottom. This gold sand is over 99% pure, recovered from the very devices that were once destined for a landfill or an incinerator in the city. Whether from the deep earth or a recycled circuit board, all gold eventually meets in the same place, the intense heat of the refining furnace. At temperatures exceeding 1,000 degrees Celsius, the metal loses its solid form, becoming a glowing, viscous liquid that flows like heavy sunlight in a jar. The pouring of the gold is a moment of pure industrial beauty, a transition from raw material to a standardized unit of global financial value and power. As it cools, the brilliant yellow color emerges from the heat, solidifying into a form that is virtually indestructible and immune to the passage of time. Every bar is tested for purity, ensuring that the final product meets the rigorous standards required by central banks and high-end jewelry manufacturers around the world. The final stamp is a guarantee of quality and origin, marking the end of a long and perilous journey from the depths of the earth. These bars represent the cumulative effort of thousands of people, from the miners in the dark to the chemists in the lab and the engineers. Stored in vaults, this gold will remain unchanged for centuries, a silent witness to the rise and fall of civilizations and the evolution of our technology. The contrast is staggering. The brutal labor required to pull gold from the earth and the delicate artistry it eventually inspires in the hands of creators. Beyond jewelry and money, gold's unique properties make it essential for our journey into the stars, protecting our most sensitive instruments from cosmic radiation. Understanding the technology behind gold is understanding the history of human ingenuity itself, a relentless pursuit of the rare, the beautiful, and the permanent. From the deep hell of Mponeng to the recycled chips of the future, the story of gold is far from over. Subscribe for more industrial insights. Communication is vital at 4 kilometers deep, where every sound and signal is a lifeline connecting the workers to the safety of the world above. Without the constant roar of these ventilation systems, the heat of the rock would bake the air, making human survival impossible in these deep shafts. Reinforcing the Earth's crust is a never-ending task, as the massive weight of the world above constantly tries to reclaim the space we have carved out. Geologists spend years mapping these ancient reefs, tracing the paths of rivers that flowed billions of years ago, carrying the gold that we mine today. Managing water is one of the greatest challenges in deep mining, as subterranean aquifers can flood a tunnel in seconds, if not properly controlled. The raw energy required to break apart the Earth's hardest rocks is staggering, consuming vast amounts of electricity and mechanical power every hour of the day. Most of the gold is invisible to the naked eye, hidden as tiny atoms within the crystal structure of quartz and other common minerals in the ore. The sheer scale of the operation is hard to grasp, a continuous flow of material that never stops, day or night, in the pursuit of wealth. Chemical balance is critical in the leaching process. Even a slight deviation can mean the loss of thousands of dollars worth of gold in a single batch. Environmental responsibility is a key part of modern mining, as we manage the waste products of extraction to protect the surrounding ecosystems and communities. In the world of e-waste, every discarded computer is a mini-mine, containing a complex cocktail of precious metals that can be recovered and reused forever. Manual dismantling ensures that the highest quality components are saved, reducing the energy needed for chemical processing and increasing the overall efficiency of recycling. The chemistry of recovery is a delicate dance of acids and bases, carefully orchestrated to target only the gold while leaving other metals behind in the liquid. Because gold is the most malleable of all metals, a single ounce can be beaten into a sheet covering nearly 100 square feet of surface. Every milligram counts when dealing with a substance this valuable, necessitating scales so sensitive they can detect the weight of a single human hair. The safety equipment for the refining process is as advanced as the technology itself, protecting workers from the extreme radiant heat of the molten metal. To the trained eye, the surface of a gold bar tells a story of its purity and the speed at which it was cast in the refinery. A single pallet of these bars can be worth tens of millions of dollars, requiring extreme security measures.